Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Unattended test VMs and idle resources can silently rack up thousands in wasted spend each month. This video gives you the tools to spot and stop that drain. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Last part, we stacked availability sets, zones, and SLAs, so your VMs stayed up when the data center didn't. This part flips the problem. All that uptime costs real money, and nobody forwarded the bill to the developer who spun up a monster VM and forgot to turn it off. Azure Advisor, a free tool that analyzes your usage and surfaces cost and performance recommendations, alone flags millions in idle VM spend every month. The average mid-sized team leaves over $2,000 in unused compute sitting on the table every 30 days. Part 5 is about making sure you don't go broke keeping everything running. 3 skills. First, you'll spot the invisible waste. Dev VMs running on weekends, unattached disks burning money. Second, you'll pick the right commitment tool and layer on hybrid benefit to cut your bill by up to 80%. Third, you'll know exactly when a 90% discount on Spot VMs makes your batch jobs free money and when it'll bite you. That's the roadmap. Maging. It's Friday afternoon. A developer needs a powerful virtual machine to test a migration. They deploy a large memory-optimized VM, complete the testing, close their laptop, and head home. The problem? The VM keeps running all weekend. Nobody notices. By Monday morning, the Azure bill is far higher than anyone expected. Stories like this happen more often than people realize. Not because Azure is expensive, but because cloud resources are incredibly easy to create and surprisingly easy to forget. Unlike traditional data centers where servers are purchased once and depreciated over several years, Azure charges for compute while resources are running. Every hour a virtual machine stays online, the meter continues. The good news is that almost every one of these unnecessary costs is preventable. In this lesson, you'll learn how experienced Azure engineers monitor spending, eliminate waste, choose the correct purchasing model, and dramatically reduce VM costs without sacrificing performance. Before you can reduce Azure costs, you need to understand what you're actually paying for. A virtual machine bill is made up of several different components. The largest cost is usually compute, the virtual CPUs, and memory allocated to the VM. If you're running Windows Server, part of that hourly price also includes the Windows operating system license, unless you're using Azure Hybrid Benefit. Storage is another major component. Managed disks, premium SSDs, ultra disks, snapshots, and backups all generate separate charges. Networking can also contribute to your monthly bill. Public IP addresses, load balancers, NAT gateways, VPN gateways, ExpressRoute, and outbound internet traffic each have their own pricing models. Finally, don't forget operational services such as Azure Backup, Azure Monitor, Log Analytics, Microsoft Defender for Cloud, and Microsoft Sentinel. When people say, "My VM costs too much," the VM itself is often only part of the story. Each optimization tool targets different parts of the bill. Reserved instances and savings plans reduce compute costs. Azure Hybrid Benefit reduces Windows licensing costs. Storage optimization reduces disk costs. Cleanup and lifecycle management eliminate unused resources. The first step is understanding which cost you're actually trying to reduce. Let's identify where your Azure money is actually going. Open Cost Management. Plus Billing, then select Cost Analysis. Start by grouping your costs by service name. This immediately shows how much you're spending on virtual machines, managed disks, networking, storage, backup, and every other Azure service. Next, filter the report to virtual machines. Now group by resource to identify your most expensive VMs. For larger environments, group by subscription resource, group environment cost center, application owner. This is why consistent tagging is so important. Without tags, it's difficult to answer questions like, which department owns this VM? Why is this server still running? Who should approve its cost? Don't optimize blindly. Start with the data. The most expensive VM isn't always the one that needs attention, but it's usually the best place to start investigating. Finding high costs is useful. Preventing them is even better. Azure Cost Management lets you create budgets for subscriptions, resource groups, or management groups. For example, you might create a monthly development budget of $500. Then configure alerts at 50%, 80%, and 100% of the budget. When those thresholds are reached, Azure sends notifications before the bill becomes a surprise. One important point: budgets themselves do not automatically stop virtual machines. If you want Azure to shut down non-production resources automatically, you'll connect budget alerts to Azure Monitor Action Groups, Azure Automation, Logic Apps, Functions, or another automation platform. Think of budgets as the smoke detector. Automation is the sprinkler system. Together, they can stop a small cost problem from becoming a major financial one. If you're responsible for development or test environments, this may be the highest return on investment feature in Azure. Open any virtual machine. Under Operations, select Auto Shutdown. Enable the feature. Choose the shutdown time. Optionally configure email notifications before Azure shuts the VM down. That's it. Every evening, Azure automatically deallocates the virtual machine. Here's the important distinction. When a VM is running, you're paying for compute. When it's stopped, deallocated, compute charges stop. However, storage charges continue. The OS disk, data disks, snapshots, backups, and other attached resources continue to incur charges. Auto shutdown won't eliminate your Azure bill. But for development environments that sit idle every night and every weekend, it can reduce compute costs dramatically with almost no administrative effort. A VM left running 24/7 costs you the full hourly rate all month long. If you auto shut down after 8 hours a day, you only pay for those 8 hours, about a third of the always-on price. That's a 67% reduction. No complex math, no commitment, just a scheduled shutdown. The exact percentage depends on your schedule, but the savings are massive. Pause and test yourself. The alert catches the overspend before it becomes a crisis. The shutdowns stop the bleed at the source every single night. Combine them, and you've erased the classic developer mistake from your environment. Imagine you're paying for a luxury SUV, but you only drive 2 miles to work. That's exactly what oversized virtual machines look like. A company deploys an application on a D64 virtual machine because they wanted to play it safe. Months later, they discover the server averages 5% CPU utilization and uses less than 20% of available memory. They're paying for hardware they never use. Before purchasing any reserved instance or savings plan, answer one question. Is this actually the right VM size? Azure Advisor analyzes utilization and recommends smaller VM sizes when appropriate. Azure Monitor provides CPU, memory, disk, and network metrics that help validate those recommendations. Right sizing should always come before long-term commitments. Otherwise, you're locking yourself into paying for resources your application doesn't need. Measure first, resize second, commit third. That's the sequence experienced cloud engineers follow. Azure Advisor flags oversized VMs based on your actual usage. It recommends a smaller size along with estimated monthly savings. You can review the suggestion and apply the resize right there. The data stays, the VM may restart, and your bill shrinks. No guesswork. Resizing a virtual machine is straightforward, but there are a few things to verify first. Before changing sizes, confirm that the target VM SKU is available in the current Azure region and cluster. Some VM families may require the VM to be stopped and deallocated before Azure can move it to compatible hardware. Using Azure CLI, you can resize a VM with the AZ VM resize command by specifying the resource group, VM name, and new VM size. After the resize completes, verify that the application starts normally, performance is acceptable, monitoring agents reconnect successfully. Always perform resizing during an approved maintenance window if production availability could be affected. Changing VM sizes is generally straightforward, but production systems deserve proper testing and rollback planning. Not every virtual machine can be resized as easily as clicking a different SKU. Some VM sizes aren't available in every region. Some hardware generations don't support every VM family. Virtual machines using Ephemeral OS disks have additional sizing considerations because the selected VM size must support ephemeral disks. Availability sets, proximity placement groups, capacity reservations, GPU workloads, and local temporary storage can also limit your resizing options. If Azure tells you the requested size isn't available, don't assume something is broken. Verify. Region availability. VM family compatibility. Ephemeral OS support capacity constraints. Hardware generation. Understanding these dependencies saves hours of troubleshooting. Let's pause and lock this in. From the sizing talk, which Azure VM family gives you high memory without the CPU overhead? And what's the one pre-commitment step that ensures you don't lock in waste with a reserved instance? Take a moment. Imagine two companies buying the exact same reserved instance. The first company spends a week analyzing CPU utilization, memory usage, Azure Advisor recommendations, and growth projections. Then they purchase a 3-year reservation. The second company skips all of that. They simply hear, save up to 72%, and immediately buy a 3-year reservation for their existing virtual machine. 6 months later, Azure Advisor recommends downsizing the VM by half. Now the company has committed to paying for more compute than the application actually needs. The discount is real. The waste is real too. Reserved instances reward good planning. They don't replace it. Always right-size before committing. Think of a reservation as buying a long-term airline ticket. It's fantastic if you know exactly where you're going. It's expensive if your plans change next month. Azure provides 2 major commitment models: reserved instances and Azure Savings Plans for compute. Reserved instances commit you to a specific virtual machine family within a region for either 1 year or 3 years. Because Azure can predict how those resources will be used, Microsoft rewards that predictability with the deepest discounts. Savings plans work differently. Instead of committing to a VM type, you commit to spending a fixed amount per hour on eligible compute services. Azure automatically applies discounts to qualifying usage until that hourly commitment is consumed. This gives much more flexibility. You can change VM families, deploy additional compute, modernize applications, or migrate workloads without losing the benefit of the commitment. Generally speaking, stable production workloads often benefit from reserved instances. Dynamic environments with changing architectures frequently benefit from savings plans. The best choice depends on how predictable your workloads are, not simply which discount percentage looks larger. Let's understand what you're actually buying. A reserved instance is not a prepaid virtual machine. It's a billing commitment. If a qualifying VM is running, Azure automatically applies the reservation discount. If no matching VM exists, the reservation continues because the commitment itself still exists. This is why reservation should only be purchased for workloads that consistently consume compute resources. A one-year reservation provides flexibility while reducing costs. A 3-year reservation usually delivers the deepest savings, but assumes the workload will remain stable for much longer. Modern Azure reservations also support options such as exchanges and cancellation policies, subject to Microsoft's current program rules. Always review the latest Azure reservation documentation before making long-term purchasing decisions. When you're confident a workload will remain stable, purchasing a reservation is straightforward. Open the Azure portal. Navigate to Reservations. Choose Virtual Machines. Select the appropriate subscription, region, virtual machine family, operating system, and commitment term. Next, choose the reservation scope. A single resource group scope limits the reservation to matching resources inside one resource group. A single subscription scope allows matching resources anywhere within that subscription. A shared scope lets Azure automatically apply the discount across all eligible subscriptions in the billing context. Most organizations prefer shared scope because it maximizes reservation utilization. After reviewing the purchase details, complete the reservation. Azure automatically applies the discount whenever eligible resources are running. No changes are required on the virtual machine itself. This is the question every Azure architect eventually asks. How much should a virtual machine run before committing to a reservation makes financial sense? There isn't a universal answer. It depends on VM size, region, operating system, reservation term, current pricing, and how consistently the VM runs. Instead of memorizing percentages, use this decision process. If the workload runs nearly all day, is unlikely to change, and will remain deployed for 1 year or longer. A reserved instance is often worth evaluating. If the workload shuts down every evening, changes VM sizes frequently, or may disappear in a few months. Pay-as-you-go or a savings plan is often the better choice. The important lesson isn't the exact break-even percentage, it's understanding workload stability. Architects optimize based on usage patterns, not marketing discounts. Quick review. Which purchasing model offers the greatest flexibility when workloads change over time? The answer is Azure Savings Plans. Which option usually provides the deepest discounts for stable, long-running virtual machines? Reserved instances, and before buying either one, what should you always do first? Right-size the workload. Optimizing an oversized VM before committing often saves more money than the commitment itself. Think of an Azure savings plan as committing to spend a certain amount on compute every hour, rather than committing to one particular VM. Suppose your organization commits to $2 of eligible compute every hour. Azure automatically applies discounted pricing to qualifying compute services until that hourly commitment is fully consumed. Those eligible services can include supported virtual machines, app service, Azure Functions Premium, container apps dedicated, AKS worker nodes, and other qualifying compute resources. If your architecture evolves over time, the discount follows the eligible compute usage rather than remaining tied to one VM family. That's why many organizations choose savings plans during modernization projects. They preserve flexibility while still reducing compute costs. Imagine two different companies. The first runs a payroll application that hasn't changed in 5 years. The servers run 24 hours a day. They rarely change VM sizes. Reserved instances are an excellent fit. Now imagine a second company migrating hundreds of workloads into Azure. Every month they resize VMs, retire applications, deploy containers, and experiment with new architectures. Locking every workload into reserved instances would be difficult. Azure savings plans allow the discount to follow those changing compute workloads. Neither purchasing model is universally better. The correct answer depends on workload stability. Stable workloads favor reserved instances. Changing workloads often favor savings plans. Experienced Azure architects evaluate both before making purchasing decisions. Let's compare them directly. Reserved instances typically provide the deepest discount, but they assume your workload remains relatively consistent. Savings plans usually offer slightly smaller discounts. In exchange, they support much greater flexibility across eligible compute services. Ask yourself 3 questions. Will this workload remain in Azure for years? Will it continue using approximately the same VM family? Will the architecture remain relatively stable? If the answer is yes, reserved instances are worth serious consideration. If you're still modernizing applications, moving between VM families, or expecting significant architectural changes, savings plans often reduce financial risk while still lowering costs. Always let workload behavior drive your purchasing decision. Never buy a commitment simply because the discount percentage looks attractive. Many organizations already own Windows Server or SQL Server licenses through software assurance or qualifying subscription licenses. Azure Hybrid Benefit allows those existing licenses to be used in Azure, reducing licensing costs for eligible workloads. Instead of paying for both Azure Compute and a new Windows license every hour, qualifying organizations can reuse licenses they already own. For Windows Server virtual machines, this reduces the operating system licensing portion of the bill. Azure Hybrid Benefit also supports eligible SQL Server deployments, where licensing savings can be even more significant. The key point is simple. If your organization already invested in Microsoft licensing, make sure you're receiving the cloud benefits you're entitled to. Failing to enable hybrid benefit can mean paying twice for the same software. One of the biggest advantages of Azure's pricing model is that several cost optimizations can work together. Let's look at a common production Windows server. First, Azure Hybrid Benefit removes the Windows Server licensing charge for organizations with eligible licenses. Next, a reserved instance or savings plan reduces the compute cost. Finally, right-sizing ensures you're only paying for the resources the application actually needs. Notice what we did not stack: Spot virtual machines. Spot pricing is designed for interruptible workloads and generally isn't combined with long-term commitment strategies for production servers. The goal isn't to collect every possible discount. The goal is selecting the right optimization for the right workload. When organizations combine Azure Hybrid Benefit, proper sizing, and the appropriate commitment model, Microsoft reports savings of up to 80% for qualifying Windows Server workloads. The words "up to" matter. Your actual savings depend on licensing, VM size, pricing region, workload utilization, and commitment choices. Let's test your decision-making. A production SQL server runs 24 hours a day and rarely changes. Which optimization should you evaluate first after confirming the VM is correctly sized? Reserved instances. Now imagine a development environment that changes VM sizes every month. Which commitment gives you more flexibility? Azure Savings Plans. Finally, if your company already owns eligible Windows Server licenses, what additional optimization should you enable? Azure Hybrid Benefit. Remember, visibility, right sizing, commitment, licensing. That's the order. Quick review. Which part of a Windows VM's hourly cost does Azure Hybrid Benefit primarily reduce? The Windows Server licensing portion. Can Azure Hybrid Benefit be combined with reserved instances or savings plans? Yes. That's one of the reasons Azure Hybrid Benefit is one of the highest value optimizations available for eligible Microsoft customers. Let's compare 3 workloads. Scenario 1. A production application runs 24 hours a day and rarely changes. Reserved instance. Scenario 2. A development subscription constantly changes VM sizes and compute services. Savings plan. Scenario 3. A nightly rendering job can restart without losing work. Spot virtual machines. Don't memorize products. Memorize workload characteristics. The workload determines the purchasing model. Suppose your engineering team processes 500 video files every night. Each job is independent. If one virtual machine disappears halfway through processing, another machine can simply continue where it left off. That's an excellent Spot VM workload. Azure Spot virtual machines use unused Azure capacity at deeply discounted prices. Those discounts can reach up to 90% compared to pay-as-you-go pricing. The trade-off is simple. Azure can reclaim that capacity whenever it needs it. Your application must expect interruptions. Spot virtual machines are ideal for batch processing, rendering, machine learning training, large simulations, continuous integration jobs, data processing. They are generally not appropriate for production domain controllers, databases, or business-critical applications that require guaranteed availability. The secret isn't buying Spot. The secret is designing software that doesn't care when Spot disappears. Every Spot workload should assume eviction will happen. Here's the life cycle. Azure allocates available Spot capacity. Your workload begins processing. If Azure needs that capacity back, it sends an eviction notification. Applications can monitor Azure scheduled events to receive advance notice before the VM is reclaimed. That short notification window gives your application an opportunity to save progress, checkpoint work, flush logs, update a job queue, or notify another worker. After eviction, automation submits a new Spot request or continues processing on another available worker. This design pattern transforms interruptions from failures into routine operational events. When engineers say Spot VMs are reliable, they don't mean the VM never disappears. They mean the application continues successfully even when individual VMs do. Spot pricing changes continuously. The exact discount depends on Azure region, VM family, current demand, available capacity. Some workloads may receive relatively modest discounts. Others may approach 90% savings. That's why architects never hard-code expected pricing. Always review current spot pricing for your region before estimating project costs. The larger lesson isn't the exact percentage. It's matching interruptible workloads with interruptible pricing. Creating a Spot VM looks almost identical to deploying any other Azure virtual machine. During deployment, enable Azure Spot instance. Next, choose the eviction policy. Deallocate preserves the disks and VM configuration, so the machine can potentially be restarted later. Delete removes the VM completely after eviction. Then choose the maximum price. If you specify a maximum hourly price, Azure may evict the VM when market pricing exceeds that limit. Alternatively, selecting one tells Azure to always pay the current spot market price and only evict the VM when Azure requires the capacity. For many batch processing workloads, this is the preferred configuration because capacity availability matters more than small pricing fluctuations. Finally, complete the deployment and verify that your workload supports interruption and recovery. Let's review. What is the biggest advantage of Spot virtual machines? Extremely low compute cost. What is the biggest disadvantage? Azure can reclaim the capacity at any time. What Azure feature provides advance notice before an eviction? Azure scheduled events. Finally, what type of application is best suited for Spot? Any workload that can safely restart, retry, or continue processing after interruption. Let's compare 4 common workloads. A production web application that runs continuously. Right-size it. Evaluate Azure Hybrid benefit if eligible. Then consider reserved instances. A development environment used only during business hours. Enable auto shutdown. Right-size regularly. A savings plan may be appropriate if compute usage changes frequently. A data analytics cluster that runs intermittently. Savings plans often provide flexibility while still reducing compute costs. A nightly rendering farm or machine learning training cluster. Spot virtual machines can dramatically reduce compute costs when interruptions are acceptable. Notice that we didn't use the same answer for every workload. Cloud cost optimization is about choosing the right strategy, not applying the same discount everywhere. Let's bring everything together. Step 1. Gain visibility. Use cost management, Azure Advisor, tagging, budgets, and alerts to understand where money is being spent. Step 2. Eliminate waste. Shut down development resources when they aren't needed. Remove unused disks. Delete abandoned public IP addresses. Right-size oversized virtual machines before making any purchasing commitments. Step 3. Choose the correct purchasing strategy. Reserved instances for predictable long-running workloads. Savings plans for changing environments. Azure Hybrid benefit for eligible Microsoft licenses. Spot virtual machines for interruptible compute. Finally, review your environment regularly. Applications evolve. Usage patterns change. Cloud optimization isn't a one-time project. It's an ongoing operational discipline. In the next lesson, we'll shift from saving money to protecting everything you've built. We'll secure Azure virtual machines using Microsoft Defender for Cloud, just-in-time access, Microsoft Entra authentication, disk encryption, and modern defense in-depth practices. That's where cost optimization meets enterprise security. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.